In this video, we will continue our previous lesson about gas. At the end of this lesson, students should be able to explain ideal and non-ideal behavior of gases in terms of intermolecular force and molecular volume. And students should be able to explain the condition at which real gas approach the ideal behavior. Ideal gas. Ideal gas is a gas that obeys the gas law or the ideal gas equation exactly. Ideal gas equation is PV equal nRT, and this equation can be derived from combination of three gas law, which is number 1, Boyle's law, number 2, Charles' law, and number 3 is Avogadro's law. Ideal gas, also known as perfect gas. Although no ideal gas actually exists, most simple gas such as nitrogen, oxygen, and hydrogen, and also noble gas show nearly ideal behavior at ordinary temperature and pressure. Ideal and non-ideal behavior of gas. So what is the difference between ideal and non-ideal behavior of gas? Okay, so we will discuss the difference in terms of volume, intermolecular force, and the other one is equation. For ideal gas, volume of gaseous molecule is negligible. But in the real gas, volume of real gas molecules is significant. Intermolecular force between the gaseous molecule in ideal gas is negligible, but in real gas, the intermolecular force between the gaseous molecule is significant. How about equation? So, ideal gas obey ideal gas equation, which is ideal gas equation is PV equal nRT. And this formula is derived from combination of Boyle's law, Charles' law, and the other one is Avogadro's law. But in real gas, the gases obey Van der Waals equation. And the Van der Waals equation is P plus AN squared divided by V squared multiplied by V minus NB equals nRT. So, after this, we will go further about Van der Waals equation. Van der Waals equation. Van der Waals equation describes the real gas behavior. And condition of real gas is at high pressure and low temperature. Van der Waals equation is modified from the ideal gas equation which consider the deviation of real gas. But why pressure real gas is less than pressure of ideal gas and volume of the real gas is more than volume of ideal gas? So, in the next slide, we will discuss why this happened. After equation of the ideal gas is modified, so when the Wolff's equation is equals to P plus N squared A divided by V2 times V minus NB equals to nRT. A is a constant which correct for the attractive force between the gas molecule, while B is a constant which correct the volume of the gas molecule. In the real gas, pressure of real gas is less than pressure of ideal gas. Why this happen? As I mentioned before, pressure of the gas is exerted when molecule of gas collide with the wall of container. So, in the real gas, the intermolecular force between the gas molecule is significant. So, in real gas, the attractive force exists between the molecule will slow down the movement of molecules. And cause less collision occur between molecules and wall of container. When the collision is reduced, so pressure exerted by real gas is lower than ideal gas, because in the ideal gas, no attraction at all, which is intermolecular force between the gas molecule is negligible. Large value of A indicate strong attractive force. Because pressure of real gas is less than pressure of ideal gas, so the factor N squared times A divided by V squared is added to the P term. Okay, how about volume of real gas? So you can see that from this diagram, the size of volume for gas molecule is equals to NB. Excluded volume, which is referred to NB. Excluded volume is a volume occupied by a molecules which their movement is restricted in that area. An excluded volume depends on the number moles or N and the size of molecules referred to B. As a result, volume of real gas is more than volume of ideal gas. So, to correct for the fact that volume of the real gas is larger than expected from the ideal gas equation, the factor NB is subtract from volume of real gas. Ideal condition. Real gas behave ideally at condition of low pressure and high temperature. But why only at this condition real gas behave ideally? Now, let's recall back about kinetic molecular theory, because kinetic molecular theory describes the behavior of the ideal gas. In kinetic molecular theory, two assumptions has been made, which is number one, volume of gaseous molecule in ideal gas is negligible. And second assumption is intermolecular force between gaseous molecule in the ideal gas is negligible. Means that the volume and the intermolecular forces between gas molecule of the real gas can be neglected at these two conditions. That's why real gas behave ideally at this condition. Let's discuss about first condition, which is at low pressure. To make it you more understand, look at to this diagram. So we have two container. This is the first container and this is the second container. You can see that number of molecules in second container is same with the number of molecules in first container. But the volume of container number 2 is bigger than volume of container number 1. To reduce the pressure of system or pressure of the gas, volume of container must be increased. Based on the Boyle's law, pressure of gas is inversely proportional to its volume. To reduce the pressure of the gas is by increasing the volume of container. So, the pistons must pull upward. So, what you can see from this diagram, the distance in the first container is closer to one another, but in container number 2, the distance between gas molecules are far apart. When the distance of the gas molecule are far apart, means that the intermolecular force between gaseous molecule is very small. So, the intermolecular force between gas molecule is negligible. Okay, and the volume of the gas molecule also can be neglected because volume of gas molecules only occupy small fraction compared to the volume of container. Thus, gas behave ideally. Now, let's move to the second condition, which is at high temperature. So, look at to this diagram. We can see that first container temperature is equals to negative 65 degrees Celsius and the second container temperature equals to 50 degrees Celsius. Means that temperature container number 2 is higher than temperature in container number 1. Then, you also can see that the volume container number 2 compared to the volume container number 1 is bigger than container number 1. Why this happen? Because based on the Charles law, volume is directly proportional to temperature to make sure that pressure of the gases is constant. So, at high temperature, the gaseous molecules gain energy. Thus, average kinetic energy of the gas molecule increase. So, molecules move faster and far apart. That's why intermolecular force between the gas molecule become insignificant and the volume of the gas molecule is negligible. Thus, the gas behave ideally.